continue our discussion on the psychrometric processes of air conditioning. So let me share my screen. Maklaro ra ba akong tingog? So please bear with me na lang no kay medyo pagaw ko ron kay naigo sa kuan. Madungog ra ba ko? Okay, thank you Simon. Okay, so another process or psychrometric process of air conditioning is heating and dehumidification, no? So, or it is increasing the air temperature at the same time, so uh, decreasing the amount of moisture content, no, of the air, or referred to as chemical dehydration, no? Another term, chemical dehydration. So, seeing increased use in modern air conditioning, particularly in industrial environment. So when air is brought into contact with a desiccant or substitution material, so just like mga silica, no, mga silica gel, so the water vapor molecules will absorb and the air will become drier. Now, as this occurs, the heat of condensation will enter the airstream, thereby increasing its temperature. So the process is essentially adiabatic or isenthalpic. Okay, constant, kuan man siya, constant enthalpy process. Oh, no heat gain. So the humidification by solar desiccants is represented on the psychrometric chart by process dry bulb temperature and decreasing humidity ratio. So, og tanaw na to siya sa graph, opposite ani, no? If this is 1, then this is 2. So, paana siya. Ang ihang slope is downward going to the right. Excuse me. Okay. Then, so dehumidification by solid decals is represented on the psychrometric chart by a process of increasing dry bulb temperature and decreasing humidity ratio. And also, constant enthalpy, no? So parallel to constant enthalpy line. So dehumidification by liquid vesicles is also represented by a similar line. But when internal cooling is used in the apparatus, the process is overall characteristics of a heating and dehumidification process are, so the dry bulb temperature increases, so syempre kay heating man, then humidity ratio decreases, dew point temperature decreases, vapor pressure decreases, RH decreases, enthalpy remains constant, and also the wet bulb, no? Because the enthalpy and the wet bulb, no, are parallel man na sila, parallel lines. So based on the psychrometric chart. So typical heating and dehumidification process are desiccant heat which or heat wells which can be configured or controlled dehumidification, or for latent heat recovery and ventilation airstreams in warm humid climates. So mo siya. So kasagaran ani mogamit na siya og mga desiccant, no? Desiccant para sa uh, dehumidification. Then another psychrometric process is evaporative cooling. Evaporative cooling is kanang gigamit sa or principle nga gigamit sa mga chiller, no? So evaporative cooling is an adiabatic process, that is there is no heat loss or gain. So the same ra na sila sa same ra sa kuan, I mean the opposite, no, of heating and dehumidification is the evaporative cooling. So parallel lang gyapon na sila, no heat gain or heat loss. So isentalpic. So when hot air stream is made to pass through with spray, the sensible heat of air vaporizes the water and the air's dry bulb temperature will fall. So mo us. So the sensible heat used to vaporize the water enters the air as a latent heat in added vapor. So thus no heat is added or removed. So with bulb temperature remains constant. Okay. So ni kanino the sensible heat used to vaporize the water that is equivalent to latent heat mo na nga no heat is added or removed ni na kuan ra ang pagtaas sa temperature niya so na compensate ra sa pag change sa iyahang phase no pag change sa phase from liquid into vapor. So just like in this figure no, so from this point 1, so this is the initial. Then if ato siyang i-undergo og process nga evaporative cooling, so ang uh, matrace na to no sa graph is ingani. So this line is parallel to the enthalpy line and also the wet bulb line no. Constant ang iyang wet bulb. So the evaporative cooling process is commonly employed to reduce the dry bulb temperature of the air without refrigeration. So it is a constant wet bulb process of reducing dry bulb temperature. So the hardware used to achieve this process usually consists of the basic components of the adiabatic saturation chamber plus some type of device. Excuse me, huh? Some type of device to amplify the interface surface area between the water reservoir and the air, no, such as weighted wick, matting, plates, spray, etc. So sa akong gimension, mo ni ang process ang gigamit sa principle sa cooling tower, no. Without refrigeration, wala kay refrigerant kay gigamit. So ang medium lang nimo is air and water, no. So we have example problem. So evaporative cooling uses heat contained in the air to evaporate water. So air temperature drops while water content rises to the saturation point. Okay? So evaporation is used in hot weather to cool ventilation air. So the process moves upward along the line of constant enthalpy or constant wet bulb temperature. So for example, from point D to point E, so na figure dere, from D to point E, no, to this is the saturated line, 100% RH. So notice that the hot, dry air points D to E with a temperature degree Fahrenheit temperature drop has more capacity to evaporative cooling than hot, humid air. So mabitaw na nga, basta kanino? Taas lang iyahang sa taas lang iyahang RH, less na ang iyahang capacity, no, sa evaporative cooling. So same sa kanang so in real life situation kanang padung muuwan, mutaas ang iyahang relative humidity. So gamay na ang iyahang capacity nga mo pabugnaw nimo no. So mo lang mubati ka og igang. So less ra ang heat exchange or ang kanang pag-evaporate no sa mga kuan mo lang nga ang feeling nimo di ba panington ka no kana padung mo igang kay dili naman ka absorb og moisture ang kuan air ana nga time no. So ani taas na kayo siya. I mean less na kayo siya no. Gamay na lang ihadaganan compared to kung Ang iya relative humidity na labita dire 30%. So dako pa siya og capacity, no? So yan na evaporative cooling manggihapon, no? Ang principle yan na. Okay. No, has more capacity for evaporative cooling than hot humid air. So points F to G with a 12 degree temperature decrease. Sige pa ngayon eh. Ihan ang ipa-plot, no? So if this is your psychrometric chart, this is the initial temperature from point D. So ato siyang undergo process nga evaporative cooling, so from D to E. So the final temperature is 71 degree Fahrenheit at 100% RH. Whereas kani same 95 siya but less relative humidity. I mean more, no? More relative humidity which is 60%. So less rayahang capacity, no? Para sa evaporative cooling. So evaporative cooling process with excuse me, with hot dry air from points D to E and with hot humid air from points F to G. So notice greater evaporative cooling capacity with dry air. No, kanino? Mas greater evaporative cooling siya. So observable features of the evaporative cooling process: constant wet bulb temperature, decreasing dry bulb temperature, increasing humidity ratio, increasing dew point temperature. So this is based on the psychrometric chart. Increasing vapor pressure, essentially constant enthalpy, decreasing specific volume. Then there's no heat loss or gain. Di ba? Kay kuan man. Because the amount of sensible heat removed equals the latent heat, no? Na kuan ra niya. So the typical hello. So sorry no na disconnect ko kadali. Okay. So yan ano, kana kung simple ra nga magpa electric fan ka. So that is evaporative cooling na siya, no? So no refrigeration needed or no kanang wala kay mga kuan bitaw nga gi kuan nga mga wa ka mo gi ka mo gamit og laing medium such as mga refrigerant kundi di kuan lang sa air, no? So that is evaporative cooling. No, a typical evaporative cooling process is the direct conditioning of air for human comfort. Conditions in hot, dry climates and other applications where sensible cooling effects are desired and increasing humidity ratios can be tolerated. So this method adds moisture to the airstream while cooling it, and so would be useful in dry and arid regions where the warm air has a low humidity. So the result of evaporative cooling is that is air that is cooler and more humid, and a surrounding that is drier. So for this reason, the process of evaporative cooling is sometimes referred to as drying. Okay. Siyempre, mo evaporate man siya. So siyempre, no, mo evaporate man. So drying siya. Drying. At the same time, decreasing the temperature. Okay. Mm. Then we have adiabatic process. The term adiabatic simply means without energy or energy loss or gain. So this refers mainly to the processes of evaporative cooling and desiccant dehumidification. So evaporative cooling occurs when warm air passes near water. So even at temperatures well below its boiling point, water molecules on the surface will absorb sufficient energy from passing air to change phase into a gas and become moisture. No, pareha ng cooling tower nga, 'di ba? Ang cooling tower magdagayday man na siya from hot basin going to the cold basin, no? So ang mupa kuana na niya is ang air, no, nga mo gikan sa fan. So as the moisture vapor then become parts of the air, the energy is transferred from Okay, balik ta. No? Mm. Okay, so both the kung ano, the evaporative cooling and heating and dehumidification, so nabilong na siya sa adiabatic process, no? Okay, no heat gain or loss man siya. So, okay, so the second dehumidification occurs when the air comes in contact with a substance such as condensed crystal or silica gel. Itong parihabitaan ng sa inyong sapatos, no? Dehumidification na siya. So such substances simply absorb moisture directly from the air. So in the process, the latent heat of vaporization is released back into the air, raising its temperature and reducing the absolute humidity. So once again, the net overall enthalpy remains the same. Amo na nga adiabatic siya. Then another process is the mixing process, no? The mixing of two different airs, no? Air streams. So from the outside and inside. So when two streams of air with different properties and flow rates are mixed, no, the properties of the resulting mixture can be determined by simple proportional mass and energy balances. Excuse me, Miss Mar, paki-mute lang sa inyong mga mic. Okay? So, just like in the kuano, application sa air handling unit, kanang i-mix nimo ang return and outside air. So in most cases, use from system is negligible and system can be modeled at adiabatic. So on a psychrometric chart, the condition of the exiting airstream must be on the line connecting the incoming airstreams. The distance along that line is determined by the ratio of the mass flow rates of the incoming streams. So for example, this in this figure, we have two different conditions of air. So point 1 and point 2. So point 2 is kuan siya, mas lesser ang iyang temperature, no, and humidity compared to 1. Then if we are going to mix, no, the two of the uh kung ano, different airstreams, so ang mahitabo kani siya kaning 3, no, kaning 3. Ano siya mag-abot? So examples of steady flow mixing process include the outdoor air and return air, no? So mixing chamber on the air handling unit. So warm stream, cold stream mixing in dual stream systems and supply air, circulated air in fan-powered terminals. So those are the examples, no? Makinahanglan tag mixing. So the governing equations for this process, the air mass balance. So the mass flow rate of the one or the first airstream plus the mass flow rate of the second airstream. So that is equal to the mass flow rate, no, of the resulting. So 3. Then we have the kuan niya, specific volume. The volume, no, over the specific volume. Okay, same naman na siya sa mass, no. The volume over the specific volume is equivalent to mass. So total energy balance, we have the mass flow of 1 multiplied by its enthalpy plus the mass flow of 2 multiplied by its enthalpy is equal to the mass flow of the resulting air multiplied by the enthalpy of that resulting air, no? Then we have, if we're going to find the enthalpy for that air, so we have H3 is equal to M1 H1 plus M2 H2 over M1 plus M2 which is equivalent to M3. Or H3 is approximately equal to VH1 plus V2H2 over V1 plus V2. No, that is if the density of one is approximately equal to 2. So psychometric process is applicable to different regions. So mo ni siya ang 'di ba sa air conditioning dili pareha og ano process. So it depends upon the region nga imuhang applyan, no? Kung asa siya applicable. For example sa mga cold countries, so dili na siya makinahanglan og cooling, no? Gawas kung mo change na pud ang ilang season. So yan eh. So there are generally four extreme climatic conditions that may involve an air conditioning system. So hot and humid. So example ang lugar is Miami. Kasi may nakaari na ning lugar ha. Basig na naka-OJT ani. No? Atong ikuanong tinuod ba ni kay kani ato base ra man ni sa kuano kay wala man ta naka-experience. Hot and humid. Where both dry bulb temperature and humidity ratio is always high, no? Taas ang iyahang taas ang iyahang temperature sa dry bulb and also the humidity ratio. So, more igangon dito dapita, no? Here, the air conditioning system is typically composed of a cooling coil with a surface temperature below the dew point temperature. So, ganong ngani man ngani man ang iyang gikinahanglan nga air conditioning because nagkinahanglan siya nga ang air nga iyang i-supply so mo nga surface below the dew point temperature so mo automatic o ato tanawon siya so maka-experience siya condensation ng air so kung maka-experience siya condensation that means ma-dehumidify siya di ba kay some moisture content of the air will condense at the same time the temperature of the air na imong i-supply will decrease or cool down, no? So, mo na kinahanglan kag cooling coil. So, that is applicable to this region, Miami. So, most siguro nga Miami heat siya, no? Igangon day ato dapita. Then another. So, number 2, hot and dry. Hot and dry. No, example ang lugar is Phoenix. Kasi nakaari na. Wala pa no. Kaya may naningog. So, basin bag na no. Mapautanan na to ilahang personal experience. So where dry bulb temperature is high but the humidity ratio is low. No taas ang iyahang dry bulb, ubos ang iyang humidity. So magkinahanglan siya og so kani ang kinahanglan niya evaporative coolers. No will be most advantageous. Evaporative cooling ang iyang gikinahanglan. So para mo reduce ang iyang temperature at the same time mo increase ang iyang humidity. Mo siguro nga hot man, no? Hot and dry mo siguro nga ang Phoenix Suns, no? Suns ang Phoenix mo init siguro adto. Then another is cold and dry. No? Cold and dry. Example, Minneapolis. So Minneapolis, so the environment is typically very dry. So in this case, the air conditioning system usually is composed of a heating coil and a humidifying device. So kinahanglan kag heating because ang temperature ato is cold, no? Cold temperature. So with the former being located upstream of the latter. So the humidifying device may be a spray washer composed of a spray chamber in which a number of spray nozzles and risers are installed. So spray washers are typically used in industrial applications where the device performs the dual function of air humidification and cleaning. So kinahanglan siya spray washers to control the humidity, no? Then dry man na siya so ang purpose niya is to increase, no? To increase the humidity. Then another we have so both of these regions kay ihang ipang-mention so is in US. So sa US alone, although one country lang siya, pero different states, different kuan, different weather no, condition. So cold and humid. So example na is shuttle, no, shuttle. So the outdoor air is cool but humid. No, taas ang iyahang humidity. Pero ang iyang temperature is bugnaw, no? Here there may be not be a need to humidify the air. And the conditioning system typically is composed of heating coil only. So ang gikanahanglan niya heating coil ra, no? Naginahanglan sa heating coil. However, because of the humidity ratio at low temperatures is low, even the RH may be high. Some humidification may be required when the dew point is low during the winter. Dili necessary nga dili necessary nga taas. I mean, dili necessary nga atong i-control ang humidity, no? It depends ra sa So, sa na siya. Depende ra sa no? Kung i-control kay o taas-taas ang iyang humidity, kung ano man siya tolerable ra man, no? As long as it is tolerable and sold siya sa human comfort nga range, then it's okay, no? So, kinahanglan siya heating coil. How about in the Philippines? Unsa may although kaning ipang mention niya is kuan no? Extreme, no? Extreme climatic conditions. Philippines asa man ka nabilong? 1, 2, 3 and 4. Unsa may naggikinahanglan na to nga process Mr. Manlawi?
Hello, sir.
How about in our region, no? Uh, in the Philippines, no? Or specifically Bohol, no? What type of cyclometric process, no? Ang ato ang gikinahanglan.
Cold, sir.
Okay, good morning. Let's back to the ball game. Klaro na ba? Ang screen?
Yes, sir.
Ni-connect na lang kong smart wifi kay bigyan ka kaya ang ano. Upat na ni nga connection ha. Mo ni mga connection na. Si faculty, they already have my own kuan wifi wag hapon. Murag ang problema ni ang baysog yun nga connection or ang internet dire. Di man siya. Mga sila. Kani asa ni di na makakonect kasi faculty dili na. Kani ray murag magamit na to. Ang problema ni is 1 hour. Pwede na maka-extend 30 minutes. Sige padayon lang ta, no? Okay, murag naputol to. Na pa ba si Mr. Manlawi?
Nga ba, sir?
So, what do you think, Mr. Manlawi?
Kuan ni sir, hot sir. O humid.
I mean, the psychrometric process that is applicable in our region. What will be the psychrometric process?
Iyo ka. Kuan sir man. Okay ba, sir?
Okay ba? Usa man lagi kinahanglan na to day.
Need o
Okay.
kabugnaw, sir.
Sa?
Need o kabugnaw.
Unsa kabugnaw og
Ang need sa Pilipinas, sir, kay kanang kuan sir ba? Pabugnaw.
so cooling. Cooling na siya. Okay, pwede ra no? Cooling. Cooling coil lang sensible. So, depende na sa area kung maginahanglan siya og humidity control. No, katong mga clean room. Kay ang humidity ani is tolerable naman swak naman sa range. Okay, padayon ta. Summer mode air conditioning process. So a basic air conditioning schematic for summer mode shown below. So kani nga summer mode depende po ni sa area ha kay lahi-lahi po og kuan. Although same nga taas ang temperature pero lahi-lahi ang humidity, lahi-lahi ang kuan. So wala siya gi-specify kung asa siya dapitang nga lugar. So this is the kuan no, schematic diagram of an air handling unit. So you have freeze air, exhaust air, then the return air. No, some of the kung ano return air is di mong gikuan gipabalik diri i-mix nimo with the outside air no kaning fresh air ani mo ni outside then exhaust air katong gipagawas na nimo ang uban nga air no only percentage lang no sa imong gipagawas nga air diri ang imong recirculate so kaning so kaning situ na ni siya condition pila iyang condition ani nga kuan or state niya no pila iyang temperature pila iyang humidity no after diri so most probably ang iyang condition ani is approximately equal ra diri di ba kay ang kani siya gikan man na diri no gikan na diri sa room then kare is ang condition sa imong outside air no sa gawas sila may iyang variable temperature sa gawas as well as the humidity. Nag-supply ni mo ana, mag-mix na sila dire no sa mixing chamber sa air handling unit nimo. Then you have a supply fan. I-feed na siya ngadto sa cooling coil. No, this is the cooling coil. So, gikan dire, nag-mix sila lahi na ni nga kondisyon, no? Di ba? Sa ani na same na dire. Ani no? Og ato siya i-graph sa psychrometric chart. Mautro na. Ma-mix naman lang kuan psychrometric properties. Then kani siya inag-agi na po niya diri no diri sa cooling coil. Ma-change na po na iyang temperature ani. Pero dili ni nagpasabot nga ang iyang temperature sa air diri nga moagi is the same no sa temperature sa cooling coil no. It depends upon the kuan the efficiency of the cooling coil. Hindi sa o nindot ba ang iyang efficiency dili ba siya kuan or sa heat exchange bitaw niya. And then some of the air nga moagi diri dili na siya mo contact no. Uban na mo bypass. So ang temperature sa air nga ni agi diri nga condition niya lahi na pod niya diri. Mulahi na pod na siya diri kay mo mix na pod tong mga ni bypass uban. No, di man nakalikayan nga na mo bypass dili mo contact sa kuan. So ang tinuod na gyud nga kuan niya kanina siya no. Ang tinuod niya kanang kondisyon nga padung na nimo i-supply. Then you have kanina then i-supply na nimo siya no. Kaning reheater battery gamiton lang ni siya kung winter no. So this is full setup kani dili na siya applicable sa tuang natay nga ni no. Wala tay nga ni. So in our region kani is kana ra sa mga country nga nasa kuan winter and summer no nga magamit niya kana so supply air na siya so supply air as on ang room ang heat and then so layout heat so bali return po continuous no so here return air from the conditioned space to no this conditioned space kaya lahi ang temperature ng air good ka ng temperature sa ka nasa iyo inagawas ng lover so lahi ang temperature og room okay siyempre may ang ito kasi siya mo temperature mo doon la so mixes with the required amount of outdoor air so na po na siya amount man ka percentage sa outdoor air ang ginhangan then 1.3 acceptable indoor air quality and kani Mr. Bochi so why do we need to have kuan mix of return air and what use freeze air only or why not return air only kadis kuan
I-mix ning outdoor air sir og kaning indoor air sir para no sir.
yes 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 loud and clear
Hindi madunggan. Lag.
madunggan
Madunggan ko sir.
yes yes
Lag ka lang.
madungog ka Mr. Buntia
Madunggan. Hello sir.
basi ako mo di madunggan mo ko sa uban
Lag ko lang ako kasama. Ay. Yes sir.
sige sige
Kailangan i-mix ang return air sir og ang fresh air gikan sa gawas para makasave ang energy sir. Murag bali i-recycle ra niya ang air sir ba para dili kayo mo exert
saan sa mixing chamber ubos na ang iyang temperature, no? So less na lang ang effort sa cooling coil nga pabugnawon ni si kani compared dire. Okay? So mo na yung rason. So the mixture is then cold and dehumidified to EDP. So EDP kani, no? So at the cooling coil. So the actual off-coil condition is represented as 5 due to inefficiency. So kanang off-coil condition kanino? So akong giingon nga katong mo bypass or bypass, no? Bypass ang cooling coil. Na uban nga o dili sa akong ingon dili kayo efficient ang inyong kani cooling coil. So nadyo mo bypass na niya. So dili tanan mapabugnaw niya. So ang tinuod na nga temperature, actual temperature nga inyohan na ma-supply is kanina, no? Si 5. Then si 5 ug si 6 parihar ba na sila? So nay possibility nga dili pariha, no? Especially kung kuan na siya mga infiltration diri dapita or dili well kuan insulated ang inyong ducting. So na maka gain siya og heat ani nga portion kay taas-taas mo travel pa man na siya. And also if the supply fan is diri siya na locate, mo ni gitawag na tog draw through. Kani is this is blow through arrangement man ni siya. Yan pabuga siya pa daw sa cooling coil. If the fan is located here, no, after the cooling coil, this is a draw through arrangement, no? So the conditioned air is supplied to the room through the supply fan, supply duct, and the ceiling diffuser. So supply air then absorbs the sensible and latent heat from the space. So yung i-absorb ng mga heat dire. So sensible and latent. So becoming the space air. So room air is returned back to the cooling unit again and forms a closed cycle. So part of the return air exhausted to balance the outer air intake and infiltration. So ang uban na ipong ipagawas, no? No, para ma-balance siya. So the psychrometric process is illustrated below for summer cycle. So yan eh. So this is the kung ano, if you're going to graph in the psychrometric chart, the summer cycle. It's your outside air. So makita na to nga iyang arrival temperature mas higher, no? Yan siya dapita diri. Then also the humidity ratio is higher. Then this is the condition, no, of the room. Kani number 2. Kani siya. Mo na iagi nimo diha. Kadto na nang gain na siya og heat, no? Naka-gain na siya og heat sa people inside or sa equipment sa sulod. Oh, mo na ang room na to gigamit. Then gimix na siya sa mixing chamber. So ang resulting nga condition kining si number 3, no? Si number 3 resulting niya. So the humidity ratio of 2 increase kare mo decrease na siya. So nasa dapita dire. It depends sa kuan percentage. This is just a representation sa graph. Kay dili necessary nga ingani gid siya. Kay magdepende man na unsa kadaghan sa imong outside unsa kadaghan sa imong room, no? Ang imong i-mix. So for example, na siya dire. Then moagi siya sa ADP, no? Or katong imong cooling coil. Kaning ADP is quality siya, apparatus dew point, no? Apparatus dew point temperature, ADP. Or sa ato pag kuan mo ng cooling coil. So dew point, so pasabot katong ma-reach niya ang iyang saturation. So inag-mix niya na diretso na siya sa 4 ha. Diretso na siya sa 4. From 3 to 4 cooling coil. No? Because ang temperature niya is below sa kuan man, below sa dew point temperature. No, muna nga ADP na siya, apparatus dew point. Okay. Sa 4 that is katong air lang ni siya nga ni close contact, no, sa imong cooling coil. Pero, so nay pero, no, na may uban nga ni bypass, di ba, sa gayon niya mga infiltration, due to inefficiency sa cooling coil. So di gid kalikayan nga na mo bypass, di tanan mo contact. So mo mix na pud to siya. So sa 5 no, sa aning ang resulting niya kani sa 5, taas na pud ang iyang temperature, no? Kay ma-mix man na siya. Then as well as the humidity. So muna ni the off coil condition. Then imo na siyang i-supply sa 6. Muna na yung supply. Supply sa 6. Ano? Nganong itaas man ang temperature sa 6? So maybe because of the kuan katong heat gain no sa pag-travel niya sa ducting. So nana siya. Diya. Kare siya kani nakapuan ni siya no reheater battery. Wala na siya kuan. Pero pwede ra po din kaning reheater battery pwede ra po siya gamiton as long as na kay required nga temperature nga supply air niya kaning temperature nga imong gi hatag niya diri sa cooling coil is kuan lang ubos ra kayo no sa human comfort. So magkinahanglan pwede ka paandar diri. Pero pwede ra pag wala ni siya no. Pwede ra na siya wala. Okay? So mo na nga dire tanaw na to og wala nang reheater battery so most probably ang iyang supply air na ra lapita dire no. Gamay ra lang ma-heat gain niya. Okay. So you may notice that the off-coil condition is represented by node 5 away from ADP or apparatus dew point 4. This is because the cooling coil is not 100% efficient, no? And some of the air going through the cooling coil does not come in contact, no? Wala na siya ni contact. And is therefore not cold to the ADP temperature or apparatus dew point. So this may be looked upon as an efficiency of the coil and is usually given as the coil cooling contact factor, no? Cooling coil contact factor, no? Ang pag-represent na to sa efficiency sa coil niya. So the bypass factor, so in most cooling applications, the air leaving the cooling coil is not entirely saturated since some air does not come in contact with the cooling coil. Mo ni ako gibalik niya na ni bypass. So the fraction of the air that misses the coil is called the bypass factor or BF. So the bypass factor can be determined from the temperature of the water supplied to the cooling coil and the states of incoming and exiting air. So the process is shown on the psychrometric chart below. So kani, for example, this is the kuan mixed air, no? Then padong siya sa cooling coil, syempre baba ang iyahang kuano temperature at the same time ang iyang humidity ratio no sa ADP. Then tungod kay namay ni bypass, balik na po siya saka, no? This is the mix na siya sa mga ni bypass air o sa katong air nga ni come in contact with the cooling coil. So the air that does not come in contact with the coil is the bypass factor of a cooling coil may be found from. So the bypass factor is equal to T2 minus T3 over T1 minus T3. So T2 minus T3 is the difference, no? The difference in temperature between sa mixed and the EDP temperature. And over sa temperature difference sa imuhang EDP o sa katong before sa cooling coil nga mixture, no? Or katong 1. Example, air enters a coil at 90 degree Fahrenheit, 60% RH, while the coil is at 55 degree Fahrenheit and the bypass factor is 0.2. What is the leaving air temperature? So, ang iyahang kaya 55 degree Fahrenheit ang iyang kanino? Then bypass factor is 0.2. Ang ipahita pilay leaving air temperature. Si excuse me, Tito, no? Dito may ipangita. Okay. Okay, so excuse me. So we can use this equation, no? Tanara Ritso. So pila may tito, 62 degree Fahrenheit, no? Using this equation. So although 55 ang iyang ADP, so 62 ra ang iyang living, no? Kaya naman hindi bypass. Then we have winter mode heating process. So ang schematic diagram niya kanay winter mode. So diri na mugana si reheater. No, diri na ano na kay reheater dire. Kato sa kuan, pwede rag katong summer ha, pwede kag na kay reheater para makontrol nimo ang temperature. Dili kay pataason nimo ang temperature sa kuan ha, basta kay masuod lang siya kay kung ang EDP nimo is ubos ra ba, no, ubos ra kayo. So imo dong kontrolon. Pero dili po siya nga na kay kuan. So dire pwedeng mo gamit kag aning duha, no? Kay preheater and reheater battery. This is for winter mode. So tanawa gi wala na ni siya, no? Naka-off na ni siya. So the schematic diagram below shows a typical plant system for winter heating. So same ra gihapon ang cycle. Akari rin rugang kay preheater. So kay bugnaw man kayo ning air god gikan sa gawas ani kung winter, di ba? So kay preheater daan usa siya mo mix. Nilang mix na niya. Agi na po siya sa reheater. Then maginahanglan na po siya og humidifier. Kadong mga spray washers, no? Spray washers. Depende pa na siya kung needed ba, no, for that particular region. Lahi-lahi man kada area. Kung needed ang humidifier, then you have to install humidifier, no? Sa iyang kani sa padong sa supply niya after sa reheater. Okay, so the psychrometric diagram. No, if we are going to graph the cycle sa mahitabo. So ang outside air, so ubos kayo, no? Winter man. Then iagi siya una og preheating. Pag preheat ano niya, increase ang iyang temperature. And then we have the room temperature nga taas-taas na, no? Yung room temperature or sudra sa iyang comfort kani nga temperature. 3. So i-mix na siya dire 2. So the outcome is 4, no? Then waagi na po siya og reheater battery. So mo increase ang iyang temperature. So sensible heating lang. Pag abot niya dire, then waagi na po siya og humidifier. So mo increase ang iyang humidity. So kaning 6 mo na ni siya ang supply air, no? Supply air. Then balik ka sa room. Then the cycle continues. Pwede ra gani og nara sa dapita dire, no? Kani si room na dapita dire. Yan naman. Basically kani si 6 halos nara na parihara na siya ni 3. Okay. So psychrometric chart showing typical winter cycle. So application of psychrometrics to cooling coil sizing. So sa sizing na pod, unsa kadako ang imong cooling coil nga gikinahanglan. So sensible heat versus latent heat. So sensible heat, so kiba naman tala no, increase in dry bulb, latent heat di sa pag kanino heat content due to the presence of water vapor in the atmosphere. So heat required to evaporate the given amount of moisture. So we have sensible heat factor or SHF. So an air conditioning process describes the change in thermodynamic properties of moist air between the initial and final stages of conditioning, as well as the corresponding energy and mass transfers between the moist air and a medium such as water, refrigerant, adsorbent, or moist air itself. So the energy balance and conservation of mass are the two principles used for the analysis and calculation of the thermodynamic properties of moist air. So the thermal properties of air can be separated into latent and sensible. The sensible heat ratio, SHR, of an air conditioning process is defined as the ratio of the change in absolute value of sensible heat to the change in absolute value of the total heat. So gato siyang tanawon ang sensible heat ratio kanang, for example kani sa may figure na to, graph. For example kani nga process, no, from this process going to this process. So ang sensible kuan lang ana niya, sensible cooling kare, no? No, sensible na siya. So kani siya kuaon na nimo ang sensible heat ana niya i-over nimo sa total nga sensible heat katong sensible heat plus latent heat. So that is the sensible heat ratio. No? Sensible heat ratio. So both in BTU per hour. So sensible heat ratio or sensible heat factor is equal to the sensible heat over the sensible heat plus the latent heat. So sensible heat plus latent heat is the total heat. Okay, ano no? So for any air conditioning process, the sensible heat change SH is equal to 60. So 60 times the VS, ang VS volume flow rate of supply air times the density, density of supply air times C, katong specific heat, no? Times the change in uh, temperature, no? T2 minus T1. Or is equal to 60 times MCP delta T, no? MC delta T. C is the specific heat constant, no? Specific heat constant. So ang M ani mass flow. Okay, density times the volume flow rate. So that is the mass flow. Kaning 60 ani gituyo ra ni siya multiplier para sa conversion lang na, no? Conversion. So the latent heat change is, so latent heat is equal to 60 times Vs or the volume flow times the density times the change in humidity ratio times the enthalpy, no? Enthalpy. HFG. So is equal to 1060 times 60 times Vs times rho times the change in humidity ratio. So where? So ang iyang kani W2 and W1 humidity ratio ano at final and initial states. So HFG so is approximately equal to 1060 BTU per pound. So it represents the latent heat of vaporization or condensation of water at an estimated temperature of 58 degree Fahrenheit, where vaporization or condensation occurs in air handling unit or package unit. So kaning 58 estimated na siya nga temperature sa AHU, no? Nagikinahanglan. So the ratio of space sensible cooling to total cooling is useful for plotting the slope of the path that supply air travels after introduction into the space. So the relationships among the psychrometric states, capacities, and sensible heat ratio are shown graphically in figure below. So kanino, gipakita niya. So for a given pair of entering and leaving air states, the figure shows that sensible, latent, and total capacities are proportional to the differences in temperature. So humidity ratio and enthalpy respectively. The SHR is defined by the slope of the line connecting the 2 points. So this is the resulting, no? The resulting heat, kaning orange. Then this is the sensible heat, no? Sensible heat ratio. This is the uh, kuan. So ang sensible heat ratio niya kung naka-vertical na siya, so 1 automatic, di ba? Kaya mo ni sensible heat. Kung horizontal, 0, no? Kaya wala man kay sensible heat kung vertical na siya because latent heat raman na, no? So Rome sensible heat factor. So the Rome sensible heat factor represents the psychrometric process of the supply air within the conditioned space. So lahi na po di siya. Yung kag sensible heat ratio o Rome sensible heat factor. Ang Rome sensible sa supply na siya mismo, no? Sa supply na mismo. Specifically sa room. Psychrometric process of the supply air within the conditioned space. So room sensible heat factor is the ratio of the room sensible and the room latent heat. No, sa room na room sensible heat over the room sensible heat plus the room latent heat, or is equal to room sensible heat over the room total heat. No? So the supply air to a conditioned space must have the capacity to offset simultaneously both the room sensible and room latent heat loads. The process is plotted on the standard psychrometric chart as below. So kani. So this is the room condition. Then this is your supply air from apparatus, ano mo ADP, apparatus dew point. Kana diha. So ang room rani mo kani. Dili ka rin, no? Dili na ning kani kundi karira tama ari ra kataman sa supply mo na manig supply because this is the mix, no, mixed of the bypass and the apparatus dew point na temperature. So ana, so ang room sensible heat kani kay mao man ang iyahang amount of temperature na i-cool down para mahimo siyang room condition na. So mo ta ingon nga ang iyang supply air temperature is dili siya the same sa iyang room condition. Then this is the room latent heat, no? The room latent heat. Then this is the total heat, room total heat. Okay? So the slope of the room sensible heat factor line illustrates the ratio of sensible to latent loads within the space. So the room sensible heat is projected on the enthalpy lines to estimate the change in uh, sensible load, no? HS enthalpy. So in terms of sensible, no? Sensible load. And RLH, room latent heat, is projected on the enthalpy lines to estimate the change in the kaning latent heat kani or the latent load. So the room total load is the enthalpy difference between the room design condition and the supply air condition. Kani og room. So this is the total room total heat. Thus, if adequate air is supplied to offset these room loads, the room requirements will be satisfied, provided both the dry and wet bulb temperatures of the supply air fall on this line. No, as long as kuan. So diri na to mahibaw-an pilay ginahanglan nga amount sa air, no? Para enough siya or sufficient siya or adequate, no? para ang iyang room requirements will be satisfied. So dapat maigo siya diri dapita. Kani ang room supply nimo mulay siya ani nga line, no? As long as ani nga line, so masud ra siya. No, provided both the dry bulb and wet bulb temperatures of the supply air fall on this line. So dapat masud siya ni para enough siya nga or sufficient siya para maka-reach ani nga room condition. So the figure above also shows a third point defined as the apparatus dew point (EDP). The EDP represents an effective coil surface condition, and the apparatus dew point temperature can loosely be thought of as the coil temperature. Muna siya ang coil temperature, di ba? EDP, apparatus dew point. Then another, we have ground sensible heat factor. So ang ground sensible heat factor, this is the ratio of the total sensible heat to the ground total heat load that the conditioning apparatus must handle. So including the outdoor air heat loads. So this ratio is expressed as, so ground sensible heat factor is equal to the total sensible heat over total latent heat plus total sensible heat, or is equal to total sensible heat over the ground total heat. So i-include na nimo tanan, no? O RSH lang, room sensible heat lang, so kanira, or room sensible heat factor, no, arira. Pero grand na, so you have to include including the outdoor air, no? So the air which is passing through the AHU coil increases or decreases the temperature and or the moisture content. So the amount of rise or fall is determined by the total sensible and latent heat load that the conditioning apparatus must handle. So the condition of the air entering the apparatus, so apparatus nga pasabot niya is katong sa cooling coil ha, no? Or katong unit nimo. And the condition of the air leaving the apparatus is plotted on the psychrometric chart as shown below. Ini. This is the outdoor, no? The outdoor air. This is the room condition. This is the mixture. So this is the ground sensible heat factor. So ground sensible heat factor line is plotted between the mixture conditions to supply air leaving temperature from the apparatus. So gikan dire, paingon dire. So from this orange, paingon sa, or brown, you know, going to orange. Paingon na na. Muna ilahin niya sa ground sensible heat factor. Ang room, asa nga ito dapita? Kani. Ang room kani ha, kani nga line. Kana. Magato siyang i-paint. Di naman siya. So yan ni ang imuhang ang room sensible heat factor kana. So mo pa ni pag-determine sa room total heat, di ba? Ang ground sensible heat factor kare. So you have to consider the mixture, no, from the outdoor. Okay. So the slope of the ground sensible heat factor line represents the ratio of sensible and latent heat that the apparatus must handle. So ground sensible heat is projected on the enthalpy lines to estimate the change in the enthalpy, no, or the so sa sensible, no, sensible heat. Yeah, enthalpy. So ground sensible load and the RLH is projected on the enthalpy lines to estimate the ground latent load. So ground total load is the enthalpy difference between the mixed air condition and the supply air condition. So notes. So the Rome sensible heat factor line in figure 1 is the line sloping between the room condition and the supply air. Whereas the ground sensible heat factor line in figure 2 is the line sloping between the mixture condition and the supply air temperature. So the apparatus dew point is the coil surface dew temperature required to accomplish a cooling or dehumidifying process. Muna sila. Okay. Then, so the air quantity. So the air quantity required of setting simultaneously the room sensible and latent loads and the air quantity required through the apparatus to handle the total sensible and latent loads may be calculated. So ato i-determine pila ka CFM ang air nga atong gikinahanglan para enough siya, no? So to supply or for the requirement of the room, no? So using the conditions on their respective RSHF and the GSHF lines. So for a particular application, when both the RSHF and GSHF ratio lines are plotted on the psychrometric chart, the intersection of the two lines represents the condition of the supply air to the space. Both the room sensible heat factor kuno and ground sensible heat factor ratio lines are plotted on the psychrometric chart. Ang intersection kuno nila represents the condition of the supply air to the space. So just like kanino? Kani sila og kare, then kani og kare. Ang intersection nila kare. Then this is the condition of the supply air. No, condition sa supply air ni. So muna siya. So muna no, kato mo to iyahang intersection. So it is also the condition of the air leaving the apparatus. So the figure below illustrates what actually happens when these supplementary loads are considered. So in plotting the RSHF and GSHF lines, so kani time naman no 9:30. Continue na lang ni nato sunod para dili ta mahinayak. Okay, taas pa ni. No, continue na nato sunod, no. Dire ang nga ni ang pagkuha sa percent o pila ka outside air atong gikinahanglan. No, kani. Okay, taas pa atong video kuan. Na may pangutana? Clarification? Hello?
Uy, batas ang ligit.
Wala ni pangutana.
Hindi kasi sila kasaki ko ako cellphone hub. Muna-muna ko naman.
Yes, Simon. Okay. Simon. Kindly unmute your microphone no para
Kanang fourth, ang sige mga schedule na to, sir, para sa klase, sir, final, sir.
katong
Naina.
katong gi-send ni nagkasabot mo ni Altia. Na may gi-send si Altia niyo siya nga nasabutan kuno ninyo.
Okay na to, sir.
Kato
So,
na.
uwa, sir, is 2 hours.
Pero once ano sa to dapita ha? Once mubalik na ang face to face, so ibalik na to sa atong original. Kay para dili ta ma-conflict sa uban.
Okay, sir. Thank you, sir.
Wag maora man siguro na yan. Kuan, Tuesday 7:30 to 9:30, Wednesday 2:30 to 4:30, and Thursday 4:30 to 5:30. Okay, Simon. Manino? Sakto ba? Mabay, naka-reflect sa inyo ha. Okay. Thank you. Wala na ilaing pangutana? Clarification? So, let us just continue tomorrow, no? At 2:30, no? Okay. Taas-taas na po. So, sorry, di po ganiha na sige gyud ka-connect. Ka-connect, disconnect. Okay, so i-check lang na to attendance ha. Para na ko i-record gawas sa kuan. Paspasan lang na to. Kindly unmute na lang, no? Once your name is called. Uy, wala man na save. Wait lang. Sa 4-8 magsugod. Ito lang tang date. Kaya para madritso na ako ko ano. Kaya ang uban screenshot mga wala pa nako finalize. September 27. Sa dansa,
Present, sir.
aggressor, alaban,
Present, sir.
araraw,
Present, sir.
asas, ayop,
Present, sir.
balbido, busbos, kagaanan,
Present, sir.
Castillion, Doldolea,
Guwapo ako, present, sir.
Duterte,
Sir, present, sir.
Kumban,
Present, sir.
Hibaya, Trial,
Present, sir.
Mawid, Nanaria,
Sir, present, sir.
Lulong,
Present, sir.
Tumutos,
Present, sir.
Par,
Present, sir.
Elianes,
Present, sir.
Pelinya,
Present, sir.
Orias,
Present, sir.
Pasagad,
Present, sir.
Ranes,
Present, sir.
Raniua,
Present, sir.
Rikerme,
Present, sir. Present, sir.
Reyes,
Present, sir.
Saludo,
Present, sir.
Simborio, Tubak,
Present, sir.
Ogat,
Present, sir.
Marquez,
Present, sir.
Villa, Theodore,
Present, sir.
Victor,
Present, sir.
Aggressor.
me na yung mga ning chat, sir.
Okay. Aggressor, boss.
Present, sir.
Iban. Simberyo.
Present, sir.
Mm. Orano. Bilarmino.
Present, sir.
Furby. Abada. Alagot.
Present, sir.
Bansag.
Present, sir.
Buntia. Saan to si Buntia? Kandog.
Present, sir. Present. Present, sir.
Kandog.
Present, sir.
Concha.
Present, sir.
Pino.
Present, sir.
Dagangon. Dano.
Present, sir.
De Los Reyes.
Present, sir. Present.
Elioremo. Escobido.
Present, sir.
Istorioso. Felicelda.
Present, sir.
Present, sir.
Felicelda na
Present, sir.
Torres.
Present, sir. Present.
Nita.
Present, sir.
Inting.
Present, sir.
Kamisola. Mag-uyon. Manlawe.
Present, sir.
Makiling.
Present, sir.
Marapaw.
Present, sir.
Ubod.
Present, sir.
Pasamba. Payot.
Present, sir.
Ramonida.
Present, sir.
Salomon.
Present, sir.
Shes.
Present, sir.
Sukurin.
Present, sir.
Talo. Timbal.
Present, sir.
Umo.
Present.
Valyasera.
Present, sir.
Bertodaso. Then, kinsa may nakahibaw aning uban nga basig percent lang ba na na-disconnect rag dali.
Present, sir.
So ato lang like
Na yung mga chat, sir. Sa phone.
May chat sila, sir.
Okay, Eliorimo. Hinita. Okay naman Hinita. Abada. Mura man siguro no? Malailain. And then sa foray. Okay? I-kuha lang na to, screenshot lang na to for documentation lang ng screenshot dili sa attendance, no. So kindly open your camera. Okay. So get ready and 3, 2, 1. Smile. Okay, thank you. So,
Salamat, sir.
God bless
Thank you, sir.
everyone.
Thank you, sir.
Have a nice day.
Thank you, sir.
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 Sir.
Thank you, sir.
Thank you, sir.